Okay, guys, so in this last example, we're going to integrate e to the x sine x. So integration by parts should be, after a little practice, should be the first method you think of when you see this. So here's the formula. Integral u dv is equal to u times v minus integral v du. And anytime you use this formula, you have to think to yourself, what do I want to call u, and what do I want to call dv? And your self answers, yeah, actually in this one it won't matter. You'll get the right answer, well, if you do it correct. If you follow through correctly, you'll get the right answer either way. So yeah, we could let u equal e to the x. So u equals e to the x. And that means automatically dv is sine x dx. So it's like you're calling this guy, this factor u, e to the x is u, and this whole thing is your dv. Okay? And then the right-hand side of that formula in red over here tells us we need to find a couple of things that are missing then. What do we need to find? Okay, so du, what's du? E to the x dx. And then if we have dv, so we need v. Yeah, so the idea is to integrate both sides of this thing. And to get v on the left side and negative sine x. Cosine x, rather, on the right side. Okay, so let's put the formula together. So just rewriting what we have here, we have the integral e to the x sine x dx is equal to, okay, put the formula together, or insert into the formula on the right side. And what's a good way to write it? Can we stick that negative out front? Otherwise, it looks like subtraction. If you don't put parentheses there, it gets a little messy. So negative e to the x cosine x is kind of like u times v. It's the equivalent to u times v. Minus integral v du. Okay, minus integral of what? Negative cosine x e to the x dx. Do I really want to write it that way? Now, I want to make it look more like the original integral. So how about, instead of writing it that way, how about I first of all take into account that it's going to be minus a negative, right? So instead of having this minus here, it's minus the integral of negative cosine x. Let's just make it a plus and not mess with that part of it. And then couldn't I stick the e to the x in front and put it in a form similar to the way the original integral was presented? E to the x, what, cosine x dx? Does everybody believe that? But then you look at that new integral and you think, we didn't get anywhere, right? Uh-oh. But I mean, it's just as hard to integrate. The integral of e to the x cosine x dx is just as hard to calculate as the integral of e to the x sine x dx, right? Well, any ideas? What do you want to try? Let's do it again. The thing you have to be careful of is be consistent. If you called u e to the x last time, call u e to the x this time. All right, so let's do it again. So I'm going to let u equal e to the x, which automatically means dv is that guy. Okay, so so u is e to the x, which means du is what? E to the x dx. Okay, dv is cosine x dx, so what is v? Sine x. All right? And so we're going to fill in, let's use green here. We're going to fill in, we're going to replace everything in this box with the right-hand side of the formula for integration by parts, right? U times V minus integral V du. But then don't forget to keep this other stuff coming along for fun. So negative e to the x cosine x plus, okay, what are we filling in the box? What's u times v? Yeah, u times v is e to the x sine x minus integral v du. So what would that be? What would be a good way to write that? Yeah, e to the x sine x and then dx. And then right about now you're thinking we're spinning our wheels, right? We're not getting anywhere. But let's look at that left-hand side. You know, normally I don't write down the original integral on the left-hand side like this, do I? So I must be doing it for a reason. You see anything interesting there? If you think of it as an equation, then you have like terms here and here. And that's the trick I wanted to show you with this problem. So the idea is I could add this guy to both sides. And then I'll have two of them over here. Do you see that? So I'll show that work like I would do in an intermediate algebra class, except this symbolism would scare the heck out of them. So if you add to both sides, it would look like this, right? We're combining like terms. And then I make it a vertical addition problem when I teach it in Math 60. So I have two of these integrals. 2 times integral e to the x sine x dx is just equal to whatever's left over here, right? Can I rewrite it as, so I like having the minus second, that's just my own preference. So can I rewrite it as e to the x sine x minus e to the x cosine x? Yeah. And then finally, remember what I'm trying to do. I'm trying to find the value of the integral of e to the x sine x dx. So what could I do to find it? Divide by 2 or multiply through by a half, right? Same thing. So I get integral e to the x, there's supposed to be another x right there. E to the x sine x dx is equal to 1/2 e to the x sine x minus 1/2 e to the x cosine x. And then I should at some point put in plus c, right? That would be easy to forget after doing all that work. So I think that's a pretty neat problem, pretty neat trick anyway.